Question 1. Find the median of 2, 3, 3, 6, 7, 7, 9. The median for an odd number of values is the single middle value once the data is placed in order. Now this data is already in order, it goes from 2 to 9 there. So we should look for a single middle value. We do have 7 scores, so that's an odd number. So there should be one single middle value, and I think you can spot that there with the 6. So our median in this set of scores is 6. Question 2. Find the median of 2, 3, 4, 6, 7 and 9. The median for an even number of values is the average of the two middle values once the data is placed in order. Now the data is already in order there, and you can see that because we have 6 scores, an even number of scores, one single score isn't possible. There are kind of 2 scores that make up the middle of that. And you can see that the 4 and the 6 are positioned in the middle of those 6 scores. So what we do is take the average of those two. Now the average of two numbers is the sum of those two numbers divided by how many there are, and that's 2. So we have a median of 4 plus 6, we add the two numbers together and divide by 2. So here our median is 5, we'd get 10 divided by 2 and that would go 5 times. So our median for this set of scores is 5. Question 3. Find the median of 5, 6, 3, 2, 7, 6, 4. Median for an odd number, and we do have 7 scores here, for an odd number of values is a single middle value once the data is placed in order. So this data is out of order as it stands, so let's put it in order. So that's the same data put in order there. And we should be able to spot a single middle value once that's done. And I think you can see that would be the 5. But it's very important that the data is placed in order before we try and identify where the middle is or the median is. So in this case our median is 5. Question 4. Find the mode of 3, 4, 5, 6, 6, 6, 7, 8, 8, 9. Now, there are a few ways to think of the score. It can be defined as the score that occurs the most often. The mode can be also the score that has the highest frequency, or the score that is the most popular. So that's all saying the same thing really, just subtly different versions of the same definition. So if you look at those scores above, which score occurs the most often, or has the highest frequency, or seems to be the most popular, and that would be the 6. So the mode of this set of scores is 6. Question 5. Find the mode from the dot plot shown below. Mode is the score that occurs the most often, or the one with the highest frequency, or another way of saying it is the most popular score. We can see from the height of the columns of the dots that 5 has the most dots, so this dot plot is indicating that 5 is the score that occurs the most often or has the highest frequency, so we'd say that the mode of this set of scores shown in the dot plot is 5. Question 6. Find the range of 17, 18, 18, 27, 32, 54. Range is the highest score minus the lowest score, and these ones are placed in order, so we can pretty easily identify the highest score of 54 and the lowest score of 17, and so our calculation for range is to take the 54 minus the 17. That gives us a range of 37 for these scores. It helped that they were in order already. Question 7. Find the range from the dot plot below. So the range is the highest score minus the lowest score. The scores for them to count though need to have a dot on them, so if they're missing a dot we can't sort of count them as scores in a set of data. But all the scores shown there, all the numbers shown, have dots on them. So the highest score is just 7, and the lowest score is our 1, and our range is simply 7 minus 1 or 6. Not too bad, that one. Question 8. Find the sum total of a set of 5 scores if the mean of the scores is 4. Our mean is found by taking the sum of the values divided by the number of values, or sum of the scores divided by the number of scores. But here we've been given a mean in the question of 4, so we'll put that under where the mean is in our formula here. And we've been told that we have a set of 5 scores, so we could put that where we've got the number of values. So we've really substituted the values from the question into the formula that usually is used to find the mean, and we'll go from there. Now, to get the sum of the values on its own, so we can get a proper answer here, we'll need to move the 5. Now, a bit like solving equations, if you move a number, you need to do the opposite operation to both sides. That 5 being on the bottom of the fraction that forms the right-hand side there is effectively dividing into the sum of the values there. So the opposite of dividing by 5 is multiplying by 5. So we'll do that to both sides in order to solve this little equation here. On the left-hand side, 4 times 5 is 20, and the divided by 5 that was in the formula and the multiply by 5 that we introduced will cancel each other out, leaving the sum of the values on its own on the right-hand side. So if 20 is the sum of the values, we can swap that around and say that the sum total is 20 for this set of scores. Question 9. Find the interquartile range of the set of scores shown below. The interquartile range is the upper quartile minus the lower quartile. So what we do first is to chop the set of scores in half. So we've got an upper half and a lower half. They're an even number of scores. So after chopping that in half there, we've got 5 scores in the upper half and 5 scores in the lower half. We find the middle of the upper half, which is called Q3, in this case 28. And we find the middle of the lower half, and in this case it's 24, it's called Q1. And the interquartile range is found by taking the 28 and subtracting the 24. So it gives us an idea of the spread of the scores. In this case we can quote an interquartile range for this set of scores of 4. Question 10. If a set of scores has a mean of 6 and a sum total of 42, how many scores are there? Our usual formula for finding the mean of the set of scores is to take the sum of the scores and divide by the number of scores. In this question though, we're asked to find the number of scores. So we're going to just rearrange that formula so that the number of scores is the item that's out the front on its own. So what we can do in this situation, it's a bit of a tricky shortcut, we can swap around the places of where the mean is and where the number of scores are, and that'll be a more useful version of the formula there for us. So if we swap places with those two, we get an adjusted formula of the number of scores equaling the sum of the scores divided by the mean. So this is only one way of doing this question. You can do it in a number of different ways, but this is how I'm doing it today. We're rearranging the formula to get the number of scores, the item that we're trying to find, out on its own there. Make it a bit easier from this point on. So the number of scores is the sum of the scores. We're told that the sum total is 42, and it has a mean of 6. So working backwards there, we have a number of scores of 7. We can say there are 7 scores in this set of scores.